All right, let's go ahead and classify these different chemical reactions. And just a quick reminder, we have the following chemical reactions. We have synthesis, we have decomposition, we have single replacement, we have double replacement, and we have combustion. And so what I will say is there's one of each type there's an example of each type below. What I want you to do is I want you to pause the video and I want you to try to identify what each type is and see how you do, and then I will go through them. So take the next 30 seconds or so to see if you can do this, and then we'll continue. So for this first one here, if you take a look, there's a single element that's alone by itself. And if you look, this zinc comes in and it replaces the hydrogen, and then the hydrogen gets kicked out, and now the hydrogen is alone by itself. And so, again, the zinc is alone by itself, but then the zinc is with the chloride. The hydrogen is with the chloride, but then the hydrogen is alone by itself. This is a single replacement. Now, we have not talked about balancing chemical equations, but these are all unbalanced chemical equations. And the reason why it's unbalanced is because we need the same number of each type of atom on each side. And so even though we haven't learned this yet, I'm going to go ahead and balance this. If you take a look, there's one hydrogen over here. There's two hydrogen over there. The only thing we need to do is put a 2 in the front here. And if we put a 2 in the front there, that's going to give us 2 hydrogens. But that 2 also multiplies the chloride, which that works out because there's 2 chlorides on the other side. So now it's balanced. And then these empty spaces here, if there's nothing there, it's assumed that there's a 1, so there's 1s there. All right. This next one, if you take a look, we're ending with carbon dioxide and water, and oxygen is one of the reactants. And so this is going to be a combustion reaction. So this is a combustion reaction. Another way of thinking about it has CH and O. So if it has CH and O, it's most likely going to be a combustion reaction, although there are some examples where it's not. But really the thing that gives it away is that there's carbon dioxide and water as the product. So if there's both of those, it's most likely combustion. Now again, this is not balanced. And we're going to learn that when you balance chemical equations, you always want to save oxygen for last. Notice how there's 3 carbons here, but there's only 1 carbon there. The way you balance this is by putting large numbers in the front that multiply whatever it's in front of. And so there's 3 here, there's 1 here, so that means we need to put a 3 there. Now, if you take a look, there's 8 hydrogens there, and there's 2 hydrogens there. And so what we would end up doing is we would put a 4 here, and that 4 would multiply this 2 to give us 8. Now notice how there's 2 oxygens here. And how many oxygens are there total over here? Well, right here, there's 6. Because 3 times 2 is 6. And then right here, there's 4, because 4 times 1 is 4. So altogether over here, there's 10. All right. However, there's 2 right here, so what we need to do is put a 5 right here, and now it's balanced. All right, this next one, it's one thing. You start off with one thing, and it decomposes or breaks apart into 2 things. 2 or more. And so this is decomposition. Again, this is not balanced. The way you balance this is by putting, so the K, the Cl are balanced. So the K and the Cl are balanced. But if you look at the oxygen, there's 3 oxygens here, there's 2 oxygens there. And what you want to do is you want to think about what can a 3 and a 2 both become? They can both become 6. So if we put a 2 here, it becomes 6. And if we put a 3 here, it becomes 6. But when we put a 2 here, notice how it changes how much potassium and chloride. Before putting the 2 there, the potassium and the chloride were balanced, but now it's not because now we have 2 potassiums and chlorines there, but only 1 here. So we have to end up putting a 2 there to fix that. And so, again, we have not learned about balancing, so that's okay. That's going to be next class, the lesson for next class period. So I'm just introducing it now just because. Okay, this next one. Notice how the barium is with the chloride. And notice how the potassium is with the iodate. That's IO3, it's iodate. But then notice, the barium is now with the iodate, and the potassium is now with the chloride. And so in this situation, the chloride and the iodate both traded places. They replaced each other, and this is an example of a double replacement. Now, let's balance it. What I want to point out is, notice how there's an iodate here, it's IO3, and there's an iodate over here, which is IO3. So notice how IO3 appears on both sides. So what we can do is we can treat IO3 as a single unit. How many IO3s are there right here? There's one. How many IO3s are over here? There's two of those. And so again, we can treat that as a single unit. So to fix that, what you need to do is put a 2 right here. But when you put a 2 there, that gives us 2 potassiums. So we put a 2 right here. But when you put a 2 here, that gives us 2 chlorides there, which happens to work out because there's 2 chlorides on the other side. And now it's balanced. Last one. We have multiple things coming together to make one thing. This is a synthesis. Now, if you take a look to balance this, you need to put a 2 here. You need to put a 3 here. And when you do that, you notice how there's 2 oxygens here, but there's only 1 there. And so to do that, you have to actually put a 2 here to balance the oxygen, but when you put a 2 there, it actually messes up these other ones here. And so again, sometimes when you go to balance something and then you balance something else, it messes up the first thing you balance. So you have to, adjust accordingly. So we actually need to put a 4 there. We actually need to put a 6 there. And now it's balanced. And again, there is a 1 right here. If there's nothing there, it's a 1. And that's it. So we went through and we classified each chemical reaction as a single replacement, combustion, decomposition, double replacement, synthesis. It's pretty straightforward. Once you get the hang of it, it's really, really easy. If you have any questions, feel free to email me. Have a great day.